So that was pretty simple, and you saw that when you defined a neural network. Okay. Now let's see how we can iterate over the data set, and that batch you actually get from your data set, how that batch is actually passed to your architecture. So I think there are a lot of different variations here, and this is, I will say, is the most complicated part when you have to train your network or when you have to design your network. And this is called data, you can say data pre-processing or data preparation. And I think from my experience, if you take like your effort as 100% in working on a deep learning project, if you are not like very expert, then most of the time, almost 90 to 95% of the time is going to be like spent in data preparation. So again, for even for data preparation, we have a lot of libraries, and like for example, for text, we have these NLTK is very popular, Spacey. So again, you don't have to write everything from scratch. I think a lot of libraries are available, so which makes your task easier. But again, this is I think a very challenging task. For audio, we have Spicy and Librosa, and of course, it might be outdated list. So there might be like some new libraries which are actually more efficient and easy to use. Again, for OpenCV, I think you might have used in the first assignment as well. So you can use OpenCV in PyTorch as well. You have Pillow, and then I think PIL is there. A lot of other libraries available. Okay, so the idea is when we are working with your data, for example, your images, then your images, they are stored in your disk, right? And then you load those images into memory, and it starts with CPU memory. Okay, so you will store those as NumPy array, and then you'll have to convert those NumPy arrays to GPU tensors before being able to pass like those images to your network. And we know that how to convert NumPy arrays to GPUs. I think we briefly touched upon that. But even before that, I think that's the easiest step. The difficult step is like how to load that data into NumPy array so that it's actually prepared for sending to your networks. Okay, so this step is called, you can say different terms. It could be like data loading, or you can say data loader. Okay, the idea is you are actually loading your data from disk, and there are a lot of challenges. So if you're working into on images or videos, one big challenge is the requirement of memory, right? It requires like huge amount of memory, so you will have to do that efficiently. The other issue is, I think if you have taken like operating system course, you know that disk IO is something like which is the biggest bottleneck in computation, any computation process, right? Because reading or writing into disk, it takes a lot of time. It's the actual like hardware operation, right? So same is like, I think it's one of the bottleneck we have in deep learning as well. So most of the time what happens is GPUs are not the limit, and of course like there are different variations, but let's say you have like sufficient memory in GPU, so it's not that processing the data from your input to output, so that all of that is done in GPUs. That's pretty fast, so you don't wait for that. Most of the time you wait for loading data from disk. Okay, so again, there are a lot of optimizations to be done there, but still I think that's one of the bottleneck. So for I think in PyTorch we have Torch Vision, which has I think a lot of interesting functions which you can use, which makes your data loading extremely easy. And again, I think this is you will understand this better when you start coding and when you will start like doing your second programming assignment. Some of this you might have seen in the tutorial today as well. So I will try to quickly go through this, and if you have any questions, we will come back. Okay, so I think one important operation which you have to perform in your data is transformation. Okay, so this transformation is, you might have your data in some format to prepare or to convert or to transform that format into something which your network accepts. Okay, so there are a lot of variations there. One actually important parameter is what should be the resolution of your image, right? Because you can't like use any image out there. I mean, if your images are have like varying resolutions, some is like 1000 cross 1000, some is 100 cross 100, so your network won't work that way. So when you're designing your architecture, you beforehand decide, okay, this is the image resolution I'm going to use, and the most important ones are like we use either 112, 112, and we can use 2 to 4, 2 to 4. Okay, so these are like some of the standards. And so what you have to do is, if your image is, let's say, 512, 512, you'll have to first change that resolution to, let's say, 256, 256, something like that, right? So all that operation, it's actually, it's time consuming, because if you think about this, changing resolution of your image, it requires interpolation. Okay, even if you have to increase the resolution, it requires interpolation. And if there is interpolation, you mean you have to compute that linear, you have to compute that linear combination for that, right? So it's computationally expensive. And so transform has like a lot of different functions which can be used to actually, so again, resizing is one of them. Then other operation, I think cropping is used. Then a lot of augmentations are actually used if you want to rotate your image, or let's say if you want to maybe perform some kind of scaling function in the image. So all of those transformations, this torch vision dot transform is actually very handy. Okay. So the way is, I think this is just one sample example which you can use. And I think if you just use this like for all the projects in this course, that I think will be sufficient. You don't need anything else. Okay. So this is like you are actually preparing this transformation operation. And this is a function which will be applied to all the images you load from your disk. Okay, so you don't have to worry about like applying to each and every image separately. We just define it as a callback function. So, and you can see like certain arguments here. So this first one is actually transforms to tensor. It's helping you move your data from CPU to GPU. Okay, you know that to tensor actually moves from CPU to GPU. So if you call it here, if you use this transform, then all the data will be automatically transformed to will be moved to GPU memory. Okay, so you don't have to worry about that. This is pretty important. Then again, the second is transforms.normalize. So this is actually making sure you normalize your values. Okay, so for example, if your RGB images are in the range of 0 to 255, you might to normalize it between 0 and 1 or -1 or 1. So whatever normalization you want to perform, you can just define it here. So for example, I think this normalize function, you have two different arguments. The first one should be like the mean values. Okay, so mean values for R, G, and B. And these three, I think, could be the standard deviation, right? So that's like one way to normalize. But of course, you can have different ways to normalize. So you can just replace that with this function. Okay, so now there are two things. When you're working on a data set, it could be like it's a well-known data set, which is already like established in the research community. In that case, your life is actually easier, because these frameworks, for example, PyTorch, they actually have like functionality to directly use those data sets without worrying about like creating new data loaders. So for example, CIFAR10 is a very popular data set for image classification, which it has like 10 different object categories. So you can just use this torch vision library to actually load this data set. All right, so then don't have to worry about anything. Okay, where the data set is located, like how many images you have, like what's the training set, what's the test set, everything will be taken care by this API. And this is just the location, I think, where the data will be downloaded if you don't have that. And train equals to true, again, this is like the training data. Download true, if it's not there, I think this API will download for you. So it's a very nice API. And this is the transform, which I was talking about. So if you define like a transform callback function like this, and you've passed that transform callback function to this argument, so all these transformations will be automatically applied on all the images of this data set. Okay, so you don't have to worry about it. So it's pretty clean. All right, so this is like transformation. This is you're defining your training set. And this is the actual data loader, which will be used to actually load your samples from disk and pass to the network. Okay, so you have this data loader API for that. And this data loader will take like the train set, which you just created. Okay, and again, this was a known data set, so you were able to do this. But if it's a new data set, you have your own data set, you will have to take care of generating this data set. Okay. Then batch size, I think very important parameter, like how many samples you will have in a single batch. It's 4 in this case. Shuffle equals to 2, again, it's a very important parameter. you always want to shuffle your samples. So what will happen is you will have your training data. So it will be a long list of images, let's say, right? So what you want is if you're selecting a batch, then if you don't shuffle the order, then what will happen is in the first iteration, your network is always going to see the same set of images in that batch. And then again, we were talking about co-adaptation, right? So if you have that scenario, then what will happen is your network is always seeing these set of, let's say if the batch size is 4, these set of 4 images as a batch. Okay, so it's kind of, it might co-adapt within those samples. So what we want is in different epochs, we want like different combination. So that's why if this shuffle equals to true, then whatever list you have in your training list, the order will be randomly shuffled, which will make sure that every iteration actually sees different combination of samples. Okay. And the next parameter is like number of workers. So probably I will say, don't worry about this. This is more of like increasing the speed of your data loader. It just tells you like how many parallel threads you want, which will actually load data from your disk. If this is 2, then you will have like 2 different threads, which will load the data in parallel. And as I said, like data loading is one of the bottleneck. So you want to use like as many workers as you can. So your network or your GPUs won't have to wait just for loading data from disk. Okay. So that was for training. Similarly, you can have your test set. It's almost the same. The only difference is train is equals to false. So this API is going to give you the test set. As I said, I mean, this is a known data set, but if you write your own data set, you'll have to take care of that. And again, this is exactly the same piece of code. It's just like you will put shuffle equals to false, because during testing, you don't want to shuffle your samples, right? It doesn't matter actually, because you're just doing inference.